So I wanted to address something that was very important, especially with regards to doing complicated things on a calculator. So what you see here before you is what's called a graphing calculator, right? Um, the wonderful thing about a graphing calculator, um, in this mode anyway, like, there's a lot of things to talk about the actual graphing capabilities, but the wonderful thing about this is you can type everything in exactly right, and you can type it in just as you see it here, as it's written, 2 divided by tangent of 36, and you get an answer. This is the answer. This is 2 divided by tangent of 36. Now, what makes this difficult to use sometimes is the fact that this calculator is designed for various things. If you look in here, this is the mode menu, and what it does is it shows a lot of different things. It shows this one does math, print, and classic. That's cool. For example, this decimal setting. If you can basically tell it exactly how many decimal places you needed to have at any given time. You could use this to round for you, like to the nearest 1 decimal place, 2 decimal places, 3 decimal places. This float setting right here means that it just floats all the numbers to you. The word float is a scientific computer science term, a floating point number, which is very interesting. I'm going to skip this one for a second because that's sort of my goal to talk about. These have a lot to do with the graphing, the different types of functions that you're able to graph. This just changes the style of the y equals line when you graph. This is interesting. This is not one that I've seen before. Sequential versus simultaneous, how the graph is posted onto the screen. Sequential, you'll actually see it sort of drawing, can't see my hand, sort of drawing the graph, as it goes, whereas simultaneous, it'll calculate all the points and then just put it right down there. Different types of numbers that you work with, real, complex, and this looks like RE to the theta I. That's interesting. That's position around a unit circle, I think. Complicated position around a unit circle. You won't talk about that in high school, not unless you have a cool teacher. Ways to display the fractions, how to display your answers. Be careful with that one, that fraction approximation. That one will give you an answer that is close, and that's sort of the point. It won't give you the exact answer. So don't use that one, period. Stat diagnostic, statistical stuff. But the one I really wanted to talk about was this one. So in geometry, we don't really talk about radians versus degrees. Radians are a different type of angle measure. It's not exactly the same, but it's sort of the, think of it like how you've got miles and kilometers, yards and meters, inches and centimeters. It's just a different metric to describe the how far around the circle you are. And oftentimes, you'll notice that radian is the one on the left. Oftentimes, radian degree measure is the default. So it is very, very, very important when you get a new calculator that you double check what mode it is in, what angle mode. We in geometry only ever use degrees, hence my screen is set to be degree mode. If I quit out of my calculator mode, you'll see right here it says degree. So you have to be very careful because radian measure is different than degree measure, and just like 2 feet is very different than 2 centimeters, 2 degrees is very different than 2 radians. 2 radians is almost a third of the way around the circle, whereas 2 degrees is very, very, very small arc, right? So why I bring this up is because a student emailed me and said, hey, listen, I'm not getting the same answer when I do it in this calculator versus when I do it in this calculator. And troubleshooting step number 1 is identifying whether or not your calculator is in degree mode. So if it does not say degree right here, if you're using this calculator, if it does not say degree, you know that you're in the wrong mode. So just be careful, all right? Other types of problems you might run into. Oftentimes, you have issues with a one-line calculator. This functions similarly, but not identically, to a 2-line calculator. If you've got a 2-line calculator like the ones we had in class, the TI-32X2S, the blue one that's got the slightly bigger window, you can, just like on this screen, you can type things in exactly as you want to see them, and then just hit the enter button and it will calculate the answer for you. On a one-line calculator, however, that is not the case. And that is why, in my crusade for everyone to have what they need, I have recommended just have a 2-line calculator. Get the TI-32X2S if you like Texas Instruments. There's a couple by Casio as well that are pretty good. And I'm sure there's other brands too. Those are just the 2 that I know I have used and I approve of. I think there's a special edition of the TI-30 that also acts as a 2-line calculator. It works sort of like this, where it'll give you the, see, it'll give you the little boxes to put stuff in. But like, when you're doing this, make sure that you're in degree mode. That is, I'm going to say 99% of the problem normally. Normally, for every 99 people who come to me with a, hey, my calculator isn't giving me the correct answer, the reason is because they're not in degree mode. The other 1% is that they fat-fingered the calculator. I'm lucky in that I have a cursor, so I can avoid fat-fingering the calculator. The thing that I click on is the thing that I expect to pop up on the screen. Okay, so there's Monday morning. There's my little thing for the day. Um, that was a question that was brought up in my email. So if you have any other questions, please feel free. Well, if you're here now, if you're seeing this, put it in the chat box. But if you are coming to this later, this has been archived on the on the YouTube channel, then please feel free to email me. Major and minor arcs for the circles. Yeah, so like, okay, could you maybe give me the problem you're looking at? I can be a little bit more specific. Assignment number 20, numbers 2 and 3. Okay, let's take a look. Assignment number 20. Oh, okay. All right. So what makes this one tough is just you've got a ton of like things that you have to figure out which one is which, right? Hold on, I'll share with you what mine looks like. Yours is going to be a little bit different, but let me show you what mine is. So here's mine. There's a really, I'm not going to say it's the easiest way. I'm not going to say it's the easiest way, but I will say that it is, to me, the least complicated. So they want the minor arcs. So the first thing you want to get rid of are the ones that are just incorrectly named. Because first of all, minor arcs only ever have 2 letters in them. So automatically, anyone that has 2 letters, just that's not going to be it. You know for a fact. So automatically, those are gone. The ones that we're left with, if they're a minor arc, they're at least properly named. The ones I want to call your attention to, the ones that are still going to not be right, are the ones in here that are semicircles. Because you look at this one and you say, okay, right here, this is a diameter, right? Going from G to D. So if I say arc GD, that is not a minor arc. Or DG. GD or GD or DG. Either of those is not a minor arc. So you know that we have to cross that one out too. So let's look, see if we see any GDs. Oh, here's GD. That's out. How about DG? Okay, so we're good there. Now here's another diameter, right? Well, that's diameter that goes from B to F. So the arc BF is also a semicircle. The arc FB is also a semicircle. So let's look for BF and FB. Oh, here's one. So the ones that I've struck out in red are either incorrectly named or they are a major arc and so not what we want. The ones that I've struck out in green, those are improperly named semicircles that we can't use either. The rest of these should be minor arcs, and so you can check all the ones that are left. Let's get a different color for that. Let's get blue. So the rest of these should be the minor arcs that you're looking for. Let's look at number 3 real quick. Let me look at number 3 real quick. Okay, so with this one, let me show this one in the stream. Okay, So let's make it so that everybody can see it. Is that, I hope that's not too small. Let's see. I think that's visible. I hope it is. So what we're going to do with this one is we're going to find the measure of arc TBC, right? TBC. So when it says find the measure of arc TBC, what I always like to do is I like to indicate which arc that is. Close enough. I'm going around these, right? Well, I know from TB, let me scooch this off just a little bit, just so we can see better. TB is 90 degrees, right? BD, since this is a semicircle here, right, just go straight through, that's also going to be 90 degrees. So those are fine. The one we have to figure out is this one. Well, if over here is 180 degrees, over here is 180 degrees, this is 126, so what's left over? Right, 54. So this is 54. Then all you have to do, since we're going from T all the way to C, is just add all those together. Number 4. Oh, so for that one, they just want CD. I don't know if you could. For that one, they just want CD. So they don't care about these two parts anymore. They just want this part. So you know that each of these is, so you can just eliminate all this. This whole thing is 180. So what's left over once we know that this piece is 127? It's not exactly the same because they want a different piece, basically. Does that make sense? It's based on the directions. If you look at the directions here, they want arc TBC. The 3 letters means that it's a major arc, so we're going the long way around the circle. So we need to catch all the pieces going the long way around. But the one that, number 4, this one, see how there's 2 letters here? They want the minor arc, which means you go the short way around the circle. So we don't care about all the other pieces. We just want the little piece that they're talking about. All right, wait, hold on, because this is not I think this understanding is not an issue of the process so much as it is the difference between what's a major arc and what's a minor arc. So, like, here, let me make it bigger. Not like that. Before, what they wanted was TBC. What they wanted was this arc. Actually, you know what? Let me do it like this. Let me copy, paste. So originally, what we wanted before was arc TBC, like this. And that tells us that we want to go the long way around the circle like this. TBC. BC. And I need to find how many degrees is this piece. In the other one, they want arc CD. Notice 2 letters. That tells us we want to go the short way around from C to D. That's this part. So we just want this angle. You know, we can do this so many different ways that, you know, whoops. We can do this so many different ways. But it boils down to, what are we actually looking at? What are we actually being told to find? So, like, look here. You bring this over here. Okay, good. So, like here, let me do a couple more just so you can see what I'm talking about. If we were talking about arc, I don't know, DBC. Notice 3 letters, we have to go the long way around the circle. Start at D, long way around the circle to get to C. So here we want this much. Whereas if I were to talk about arc DC, see how these two are basically like the opposite pieces? Major arc, minor arc. Here the opposite one of this one would be CT. Or TC. It doesn't matter. It doesn't matter which way you go. You can go either way. It doesn't matter. You can start at C, go to T, start at T, go to C. It's really your preference how you want to do it. This is minor arc because it's less than 180 degrees. Number 8. Okay, got you. So in order to explain this one, I think it's a lot easier to begin by trying to explain this. If I asked you if this radius is 54 and this radius is 3, you'd be able to figure out what the circumference of the one on the left and the circumference on the one on the right is, right? Pi d. 54 is the radius, so the diameter is 108. Three is the radius, so the diameter is 6. So you know how to find the circumference here, right? And you know how to find the circumference here. What is the difference? If I were to jog around this track versus I were to jog around this track, how much more would I have to run here than I would have to run here? Well, the distance around this one is 108. The distance around this one is 6. Each of those times pi. So 108 pi minus 6 pi. The difference, here I'm trying to write a B. Let's try and write a D. Is 102 pi. Right? So the thing of it is, you go through, and it doesn't matter where these circles are located. This one is over here, this one is over here. But if I wanted to figure out what the running distance around the track was here versus the running distance around the track here, I can do that. That's simple. That's very easy. What they do, And the way that they do this spin on this problem is instead of having the circles be just sitting right next to each other, this problem, they make them concentric. Let's see if I can make them concentric here on this. Hey, that's close enough. And then they tell us some information, right? They tell us that the radius here, I want to click on that. There we go. The radius here and then they tell us, so the radius here, if this is 5, and then this distance here is 12, what we can do is we can work with that. We can say, all right, hold on a minute. I need to figure out, if I run along this track, how much do I run? If I run along this track, how much do I run? And then what's the difference, right? So I think that's what they're asking. That's the whole point of this problem. How much farther does the outer rail travel? How much farther do I run along this track than if I run around this track? Well, let's figure that out. So the small one, very easy, exact same thing as what we did before. Right? The big one, there's a little bit of confusion because I am not given the radius directly, right? I'm not given the actual radius. I'm given the pieces of the radius, but not the whole thing. Well, I know what this piece is. And I know what this piece is. What's the whole radius? The whole radius is 5 and 12, which is 17, right? That's the whole thing, right? Well, that's the radius of the outer one. So that's the radius. The diameter is 34. So how much farther when I run along this track than when I run along this track? Well, what's this minus this? Number 9, let me see number 9. So, okay, with that one, remember that we are trying to find the length of the arc, right? We're trying to find the arc length. Basically, you want to go through and you want to find the arc length. They tell you basically so like, okay, I don't know why I'm trying to do that with my mouse. I've got this thing here. What they want you to do is basically just find the circumference of the one small piece. The whole point is that instead of having all 360 degrees worth, we just have 81 degrees worth. It's basically like a fraction. So it's like it's 81 degrees out of 360 of pi d. So the radius here is 12, so the diameter is 24. And here's the whole circumference if it was the whole thing. So now all we want to do is just simplify the fraction. Which, I don't know, to me, I think that's probably the hardest part. Like, because 81, 360, let's see, I know there's a 9 on top and on bottom. I'm going to divide by 9 on top, divide by 9 on bottom, and then I can work with this. I know that there's an 8 here on top, an 8 here on bottom. Now I can do my multiplication. 9 times 3 is 27 over 5. This is in simplest fraction form. The real question becomes, how do they want it? It says, simplify your answer, type an exact answer using pi as needed. So the way I've done mine, that is exactly how it should have been left. So I would enter 27 pi over 5 like this into the answer blank right here, like that. Some of them are going to ask you to write it as a decimal rounded to the nearest whatever, but this right here, 27 pi over 5, for that problem is exactly what you should be doing in terms of your answer. How did I simplify the 24 again? Okay, let me jump to a different page real quick. These are the things that matter. Well, we need to identify what goes in the top, what goes in the bottom. Here, this 24 is in a numerator. It's a whole number, so that number's in a numerator, right? The 81's in the numerator, the 360's in the denominator. Anything in any numerator can cancel with something in the denominator. You just can't do double duty. So if you start, like I could start with the 24. I could say, all right, well, hold on. I know that there's to be honest, I think there's a whole 24 up in here, right? I think it's 24 times 15, but let me double check. Yeah, okay, so what I could do is I could divide the top by 24 and the bottom by 24. 24 divided by 24 is 1. 360 divided by 24 is 15. I'm just doing it in pieces so I don't have to do it with a big number. 81 and 15, we look at that. What do they have in common? Well, 3, right? 81 divided by 3 is 27. 15 divided by 3 is 5. And what we've got left over, this is no longer useful, is what's in blue, 27 over 5. Or you could do it the other way. You could instead have worked with the 81 first, like could have started breaking down the 81, the 360 and the 81, there's a 9 in common. I think that's what I said before. 81 divided by 9 is 9. 360 divided by 9 is 40. And then I look here, 24 and 40, what do they have in common? Well, they've got an 8, right? 24 divided by 8 is 3. 40 divided by 8 is 5. And now look, I've got these numbers left over on top, these numbers left over on the bottom. 9 and 3 on top, 9 times 3 is 27. 5 is left over on the bottom. And look, either way I did it, I did get the same answer. That's very, very important. Regardless of which way you go, you should still get the same answer as long as what you've done is mathematically correct.